All right, let's look at the geometric construction of a cardioid, which is a heart-shaped curve, which makes sense that it's called a cardioid, right? And I'm going to try to derive the polar equation for this curve. Right, so let's look at the construction. I'm going to start with two circles with radius A, like that, and put them side by side, and they are intersecting at the origin. I'm going to roll the right circle along the left circle, and I'm going to keep track of that red dot on the right circle. Right, so I'm going to start rolling. Right, so we're going to keep rolling without slippage, and I'm going to keep rolling, and it's going to go all the way around once. Right, so let's try to go all the way around. Right, so as you can see, once it goes all the way around, it's going to create this beautiful closed curve, and this is called cardioid, and it does look like a heart. Right, so I'm going to use this construction to derive the polar equation for this curve. Right, so I'm going to just start over a little bit, and then if you observe the origin and the red dot and the centers of those two circles, you can see that they form an isosceles trapezoid. Right, so I'm going to freeze this right here, and you can see that we still have the isosceles trapezoid there. So I'm going to pull this out and then blow it up a little bit so that we can see it better, right? So which looks like this, right? And we're going to try to express r in terms of theta, right? R is the distance from the origin to the red dot, right? So on the side, since those are radii, so we know that those are A, right? And the bottom side is a combination of two radii, so it's going to be 2A there, right? Then I'm going to drop the perpendiculars from the both end of the top side, so it's going to look like this. And you can see that there's a rectangle there. We know that the bottom side is going to be also R. And then if you look at the bottom side of the side right triangles there, you can just do A times cosine of theta. So we have A times cosine of theta on both ends. So you can see that we can express R as start with 2A, then you subtract A cosine of theta from both sides. So R is going to be 2A minus 2A cosine of theta. Then by factoring out the 2A, we have 2A times quantity 1 minus cosine of theta, which is the polar equation we were looking for. All right, that's it. I hope that this was clear.